Salutations! We have another mystery to solve together. It appears our services have been retained to solve the mystery of the compound naming tree. Not Dan is on the case. It's... There I was, trying to solve a simple case of the Mondays, when I discovered strange markings. Fortunately, they were right behind me. Yes, very strange indeed. This was clearly scrawled onto the wall by someone desperately trying not to sing with the choir invisible. But I am here to unravel the mystery. Let's see. Down here we have obviously some ionic compounds, because all of these compounds have a metal and a non-metal, or in the case of these two, the positive ion and a negative ion. So these are clearly ionics, and over here we got carbon, oxygen, hydrogen, oxygen, phosphorus, oxygen. Well, yes, these are all non-metals, making these covalent compounds. But what is the meaning behind the tree? I've got it. This must be a way to help us understand how to write the names of these compounds. So yes, first question clearly must be, is the first element a metal? Clearly, that is the question, which there are only two answers, yes, which are yes and no. Now, if the answer is yes, we have another question to ask. What might that be? Well, these metals over here, copper and iron, happen to be, yes, transition metals. So there must be something about that, because magnesium and lithium are not transition metals. So the next question must be, is it a transition metal? All right, and clearly there are only two answers there, yes and no. So if the answer is yes and it is a transition metal, we can see from these examples there must be a Roman numeral in the name. So yes, we will use a Roman numeral. What do these Roman numerals represent, you ask? Well, transition metals are metals that have multiple charges. Yes, and so the Roman numeral here must equal the charge of that specific ion, that specific metal. Yes. All right. Now, if the answer is no, and it's just a normal ionic compound, well, we are simply going to just write the name as we see it on the periodic table. Yes. Write the name. All right. But if the answer to the first question is the element of metal, if the answer is no, well then clearly we have a covalent compound and a totally different series of names, like carbon dioxide and dihydrogen monoxide, and this tetra phosphorus decaoxide. Those are prefixes. Yes, so if we have a covalent compound, then what we do is we use prefixes. And what do the prefixes represent? Well, they clearly represent the subscripts, right? The number of atoms found in that particular formula. So let's go through the first 10 of these prefixes, right? So 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. But do we use all of these prefixes all the time? Well, clearly from this example right here, carbon dioxide, even though there is only one carbon, no, we do not use mono on the first name. We can use the other prefixes on the first name, and we can use mono on the second name, but clearly not on the first name, right? So no mono on the first element. Okay, and there is one thing though that we have not yet mentioned, and that is how to end the name. So as we see, they all tend to end in this suffix ide, I, except for the polyatomic ions, which we simply just write them as it is. So clearly, the rule here is that all names end in IDE unless it has a polyatomic ion, in which case we simply write the name of that polyatomic as it is. So there we go. I solved the mystery all on my own using my own smarts. That's right, eat your heart out, Benedict Cumberbatch. There's a new Sherlock in town, and his name is not Dan. Check you later.